You're watching the third lesson in mechanical systems. In this lesson, we'll be talking about the different classes of levers. So in the second lesson, or in the introduction of levers, we talked about what levers were. We talked about what they did and how they did it. Now we're going to talk about how there are different kinds of levers. They're called classes of levers. So there's the first, second, and third class. So take a quick look at these three pictures and see what differences do you notice between the first, second, and third class lever. Right? So we'll move on from there, and hopefully you figured out the differences, and why those differences are there will make a lot more sense as we go along. So we know what a lever is and how it works, right? A lever is a flat bar that turns on a fulcrum. And you know that a fulcrum is your turning point. The fulcrum is where the lever is turning. So there are levers everywhere. You got your seesaw, classic. You got your shovel. You got your hammer. You got your wheelbarrow. And you got your crowbar. All of these things are different kinds of levers, and all of them have their fulcrum in different places. So, what kinds of levers are there? There are three kinds: first class, second class, and third class. You may see, oh, that's where the load is, that's where the force or effort is, right? Now, you can see the arrow here. The arrow can come down here. You don't have to get confused by that. It doesn't really matter. But you can see that the load is here and the effort force is here. This means that this is the load arm, this is the effort arm, and the fulcrum is in the middle. In the second class lever, we see that the load is in the middle, the force is on the other end, and the fulcrum is on the other end. And in the third class, we say that the fulcrum is on one end, the load is on the other end, and the force is in the middle. So the difference between the classes is what's in the middle. In a first class lever, the fulcrum's in the middle. In the second class lever, the load's in the middle. And in the third class, the force or the effort is in the middle. So let's talk about the first class lever. This is a lever that has its fulcrum in the middle and the load and effort on the ends. So this is a typical lever. This is basically your seesaw. Right? You have the effort on this side, lifting or changing the height of the load on this side. So the advantage of a first class lever, the reason why you want to have a first class lever is because they reduce the amount of force needed to lift the object. And they're very precise. They're very precise. So a hammer, removing a nail with using a hammer is an example of a first class lever. You have your fulcrum here, right? Well, here, basically here, right? And you apply the effort here. So this is your effort arm. This is the effort force, this is the effort arm. It's turning on this point. This is the load arm. And what you're lifting is your load, the nail. So this is your load. So it's a first class lever, right? The fulcrum's in the middle. Effort, effort arm, load, load arm. Same with scissors. Effort, so then this would be your effort arm. This is the fulcrum. This is where the scissor blades are turning. And you have your load arm. That is where the load is. So first class lever allows you to lift an object with precision. And they reduce the amount of force needed. Second class levers. These are levers where the load is in the middle and the fulcrum and effort are on the ends. So the turning point is on the end. The load, whatever you're lifting, is in the middle. And the effort is on the far end. So an example of that would be, well, bottle openers and nutcrackers, right? So you have your load arm here in the middle. You have the turning point there, because when you try and open a bottle, the effort is going to be pushed up, right? So that means the effort arm is going to move a distance. The fulcrum is going to turn this way, and the load is going to pop the cap off. The load arm is going to pop the cap off, or the load. A nutcracker is another example, right? This part is your effort arm, right? This is where you're applying your force, your effort. The load arm is here. I'm going to use a different color. The load arm is here, right? Because that's going to the load. And the point of turning is right here because it's turning away. The nutcracker's turning away at that point. So that would make it a second class lever. These kinds of levers reduce the amount of force needed to lift an object by a very large amount, right? They allow you to reduce the amount of force needed a great deal. The third class lever, this kind of lever has the effort force in the middle and the load and fulcrum on its end. So the effort is in the middle. So that sounds kind of weird because if you look back at a second class lever, right, you may be asking yourself, well, where's the load arm? Well, the load arm is here. I'm going to use green for the load arm, right? That's the load arm all the way up to the load. That's the load arm. But the effort arm is all the way to the end. So it's usually double the length of the load arm. So second class levers allow you to always have your effort distance much, much longer, or at least twice as long as the load arm. And again, from review, if your effort distance is larger than your load distance, or effort arm is larger than your load arm, then you need less force to lift the load. So this tends to increase the amount of, it tends to decrease the amount of effort you need and increase the amount of weight you can lift, or the amount of force you can lift. Well, the opposite is true with third class levers, right? With third class levers, you're able to not move large loads. You can't move large loads using third class levers. So third class levers are weird because they're the exception. Third class levers are used for power and for speed. For power and for speed. So here we have the hockey player. The effort is applied in the middle of the stick, right? That's where you're applying your effort. The turning point is up here. That's where the hockey stick is turning, and you have your load here, right? So it's used to increase power and speed of light objects. So we're going to do some practice in class. Hopefully this made sense of the three different types of levers. The tricky part is remembering that a third class lever doesn't actually make it easier to lift something. It actually makes it easier to shoot things very fast or far, or to launch things, right? A second class lever, well, the effort arm is always at least twice as long as the load arm, and so you can always have a large amount of force. And with first class levers, they allow you to increase the effort arm larger than the load arm, and they're very precise. So hopefully that was helpful, and I'll see you next lesson.